All right, so today we're looking at 7-3, identifying similar triangles. Very, very, very close to identifying congruent triangles. Do you remember your congruent triangle theorems? What were they? SSS, what else? SAS, what else? AAS, and then what was the other one? Did we say SAS? We said SAS. And then ASA. Can you have SSA? No. Not for congruent triangles. So very similar postulates you're going to see. But for postulate 7.1, we have learned that two triangles will be similar if you can prove 2 out of the 3 angles are equal. It's called your angle-angle similarity theorem. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the angles are similar. These only occur in triangles, by the way, so you cannot apply these to quadrilaterals. You can't say, well, if I can prove that 3 out of the 4 angles of a quadrilateral are congruent, then the quadrilaterals are congruent or similar. Nope, doesn't work that way. Only works for triangles. So as you know, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles must be congruent because they add up to 180 degrees. And we have found that when all 3 angles in a triangle are the same, that their corresponding sides will be proportional. And so it shortens up what you did in last night's homework. Last night's homework, you had to prove 6 things congruent or proportional in order to prove that the figures were, well, if we're looking at triangles, 6 things, in order to prove that those figures were similar. This is now cutting down your work. So instead of proving 6 things, you only have to prove 2. All right, the next postulate is Sss Similarity. We have also found that if the measure of the corresponding sides of 2 triangles are proportional, that's all 3, then the triangles are similar. So it kind of backs up to this one. If essentially 3 of the angles are congruent, then the sides are going to be proportional. This one basically says if the sides are proportional, then the 3 angles in the inside are going to be congruent, and therefore the triangles are similar. So we only have to prove 3 out of the 6 things for SSS. And then the last one is side angle side, SAS, similarity. And you're going to have to tack on the word similarity. You can't just say SAS, because otherwise I don't know if you're talking about the congruence theorem or the similarity theorem. So if the measures of 2 sides of a triangle are proportional to the measures of 2 corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So it's really important that it's the included angle between the 2 corresponding sides. So again, we can't have ASS, which is a bad word, whether you spell it forwards or backwards. one more little bitty theorem. It's only important in proofs. Oh yeah, we get a proof today. Last chapter proofs, I promise. So Theorem 7.3 says similarity of triangles is both, is not both, but is reflexive, symmetric, and transitive. So those properties can be used when proving triangles similar. Okay, you ready for the example? Can I take this away? Okay, so then example 1. Says in the figure below, segment AB is parallel to segment DE. The measure from D to A is equal to 2. The measure from C to A is equal to 8. And the measure from C to E is equal to 3. So here's your picture. And your job is to show that the distance from C to B is equal to 4. So now you're going to start to see pictures where you have overlapping triangles. Remember that we have to first determine that we have similar triangles before we can apply any proportions to this. So I have this triangle here, CDE, the little one, and I have the big triangle right here, CAB. Okay, so these two are overlapping each other. When you look at proportional sides on overlapping triangles, this side right here on CD corresponds to what side on the big triangle? CA, okay? So if I have just AD and I have just CD, I have to add those together to get that whole corresponding side. So for right now, until I tell you otherwise or show you how to do it otherwise, you cannot set these proportional to each other yet. We'll talk about situations where you could. But they did tell you that AB is parallel to DE. So I'm going to put some parallel markers in here. And we know a lot of things about parallel lines. All I have to prove in order to use any proportion for corresponding sides is that the triangles are similar. I can either use AA, SSS, or SAS. So with parallel lines, that can prove a lot. First of all, if I make this a single arc mark, isn't angle C exactly the same angle on triangle CDE as it is on triangle CAB, since they overlap? They both, and I don't know what the angle measure is, but C is the same angle measure on both of them. So I know that angle C is congruent to angle C because they have it in common. So that's one angle measure right there. So I've got A. All I have to do is use my parallel lines right here to prove another set of angles congruent. So on parallel lines, don't I have corresponding angles that would be congruent here and here? Or couldn't I choose here and here? I have a choice. So I'm going to put double arc marks here and double arc marks here. I'm going to choose those two angles. And so then I've got angle, and I have to name angle D with 3 letters. So I've got CDE is congruent to angle CAB because corresponding angles are congruent on parallel lines. So now I've proven my second A. So this is a mini proof, so to speak. We're not doing it in a formal proof. And so then I've got, therefore, I have to write a triangle similarity statement. It's very close to a triangle congruent statement. But I'm going to say, therefore, triangle CDE. And we're going to use this tilde, which is a squiggle. I call it a squiggle. Technically, it's a tilde. This is similar to triangle. What, on the triangle, this whole big triangle, what angle corresponds to C? C. What angle corresponds to D? A, right? And so that leaves B. So by AA similarity. And you can just abbreviate it as SIM. So now that I've proven the triangles are congruent, now I can show that CB is equal to 4. So let's put in the other information that they gave us. DA is 2. CA is 8. So from here to here is 8. And then CE is 3. We need to show that this whole distance here is 4. So what I would prefer is to let that be X, and we'll go from here to here. Eight is this side on the big triangle. What side on the small triangle corresponds to 8? DC. Do you know the measure of DC? Isn't this 8 minus 2, which is what? 6. So the measure of DC is 6. We did that on night before last homework, right? And then I don't know what this is. I'm hoping it's 4. But isn't this the corresponding side, CE to CB? Okay, so I'm going to set up a proportion. I'm going to take big is to small. That's how I'm going to set up my ratios. I'm going to take the big triangles corresponding sides to the small triangles. So the big triangle, CA, corresponds to the small triangles, CD, as the big triangle, CB, corresponds to the small triangles, CE. Any questions as to where I got those? So I've done big over small, big over small. Then I'm just going to fill in the information that we have. So CA is 8. CD is 6. And then CB, we're going to let be X, and hopefully X will turn out to be 4. and then CE is 3. So all that's left is to cross multiply and solve. So I've got 6x is equal to 24. When I divide by 6, what does x equal? 4. Therefore, the measure from C to B is equal to 4. Because they use that word show, I had to be more specific in my work. I couldn't just do the scratch work and come up with the answer. All right, let's do one more type of example, but this time we don't have to show, we can just do the math. So example 2. You're going to explain why. So we have to do a slight explanation. Explain why the pair of triangles is similar. So that's pretty much the same as what we just did to show that the previous examples triangles were similar. Then you are going to use the given information. That's really good handwriting, isn't it? Use the given information to find the value of x and y. So here's your picture. So there's all the information you need to answer their question. Will somebody let Kaylee in, please? Nope, it's not Kaylee. So I want you to look at that, and I want you to determine how the triangles are similar. What triangles, what pair of triangles are we talking about? What are the two triangles? Name one. RSU, that's the big one, right? And what's the small one? VTU, right? So those are the pair that you're looking at. They're overlapping. What do these tell you? They're parallel. So parallel lines don't tell us anything about length congruency. The only thing that you can conclude from parallel lines is angle congruency. So what theorem are you going to use to prove the triangle is congruent with? AA, SSS, or SAS similarity? Is that? Can I prove, I have to prove the triangles are congruent before I can do any proportional testing. So can I prove sides congruent? No, I have no information about that. What I can do, mostly because I'm missing this X here, what I can do is prove angles congruent, right? So you well, you don't absolutely have to, but the easiest angle to prove congruent is the overlapping angle that they have in common, the U. So my very first step, because they said explain why the pair of triangles is similar, I'm going to say that angle U is congruent to angle U. So there's my A. I'm going to put a semicolon. Since segment VT is parallel to segment RS, corresponding angles are congruent. So we're going to choose a set of corresponding angles. Does it matter which set I choose? Not really. So I'm going to choose this set along with this set. Aren't those corresponding angles? So because of what I said here, I can now claim that angle RSU is congruent to angle VTU. Semicolon. Then once I hit that second angle, now I can state the triangle congruent statement. So now I can say that triangle RSU is similar to triangle, on the small triangle, what angle corresponds with R? V. What angle corresponds to U? U. And so that leaves us with T. By what theorem? What theorem did we use? Angle, angle, right? By angle, angle similarity. So that's kind of the process you have to go through to explain and or prove why two triangles are similar. All right, then the second part of this question is saying, find the values of x and y. So you need to set up proportions of corresponding sides. So again, I'm going to choose to go biggest to small. You could go smallest to big, that's fine, but I'm going to choose to go biggest to small. Yes.
Up top, the triangle congruent statement. You said RSU, and when you say VT.
Oh, yeah, thanks. Good girl. So RS, you're right, this is T. I was choosing the wrong one, huh? Let me just write that above. VTU. Good catch. Do you see why she said that? Oopsies. All right, so I'm going to go biggest to small. So what side on here, bless you, do I have a big side and a corresponding small side that I know both numbers to? There's no variable. So I know RU. What's RU? What's the distance? 12. So I'm going to have 12. 12 is to, what's the corresponding side to 12? What value? 3. So this side right here. As now I have to go biggest to small again. So I have this side 20. Does that correspond to what? BT, but that's not one of my variables, right? So what else do I have? What corresponds to my x? Oh, I forgot to put my y in here. I guess that would be handy, huh? Here's y. Now 20 corresponds to something, doesn't it? Doesn't it correspond to y? So cross multiply and solve. You can reduce first if you like. You don't have to. And then divide by 4. Don't you get y is equal to 5? So then for your third one, how are you going to solve for x? I'm still choosing to do biggest to small. So I'm still going to choose the 12 is to 3. I'm still going to use that full side length. I would not use this in case I made a mistake. I don't want to use that in one of my proportions in my second proportional statement because I could have made a mistake. This whole side on the big triangle, which is 12, right, corresponds to this little side on the little triangle. Does that make sense? Okay. So then the x is on the small triangle, right? So won't the x go down here? What side corresponds to UT on the big triangle? US. What's the distance of US? 12 plus x, right? Or x plus 12? It is not just 12x. You don't multiply them, you add them together, right? So this one's a little bit more complicated. I definitely, in this case, would be reducing the 3 into the 12 and the 3 before I cross multiply. So I got 4 times x is 4x equals 1 times x plus 12 is just x plus 12. Subtract x from both sides. 3x is equal to 12. Divide by 3. Doesn't x equal 4? Alright, so then you might have some proofs to do. Last chapter of proofs. Can I flip this? Okay. So make sure you write down the given, the prove, and the picture. So this one, it comes from page 359 in your book, and this is number 29. I did not assign this to you, but this is number 29. We're going to do it together. So given segment LP is parallel to segment MN, you are to prove that LJ is to JN as PJ is to JM. So this is a proportion, and then here's your picture. I have a trapezoid. With diagonals. Do you remember that thing called CPCTC when we had congruent triangles? Well, we're going to have something similar to corresponding parts of congruent triangles are congruent. But instead, we're going to say corresponding parts of similar triangles are what? Are not similar, they're what? They're proportional, aren't they? Remember, corresponding parts of congruent triangles are proportional as far as sides are concerned, right? So that's our CPCTC here, only you can't use CPCTC because it doesn't follow those letters. So I'm going to make you write this one out. So let's look at the given, and we're going to pre-plan our proof. So the given says that LP, right here, is parallel to MN. Doesn't that mean that I have two transversals? And with transversals, and we're specifically going to be looking at this triangle here. See that triangle there? And this triangle here. See those overlapping triangles? Because look at the proof statement. LJ. Oh, maybe I looked at the wrong triangles. So LJ belongs here, right? And JN belongs here. PJ is here. And JM is here. So actually, what triangles are we looking at? This is one. Right? There's one. And then my second one is right here. Isn't that the second one? The only reason why I know that is because I looked at my proof statement. LJ is right here. And JN is right here. So what they're saying is LJ is to JN. These must be corresponding sides on the triangles. Are the triangles oriented correctly? We'd have to reflect it down and then reflect it horizontally, wouldn't we? So vertical and then horizontal. PJ is here and JM is here, so these must be corresponding sides. So we have to prove that those sides are proportional. Before we prove that, what do we have to prove? Before you can use a proportion, what do you have to prove? We've talked about this today already. That the triangles are similar. So I have to somehow use this one given to prove that I have similar triangles. It's parallel lines. What's the only thing that we can use in triangles with parallel lines? Angles. So we're going to have to prove again by AA similarity. Okay, so that's what we're going for. Looking at these two triangles, what angles can you prove are congruent immediately with no help at all? We could do these angles because they're vertical. You could put that into your proof as one of your angles. We could shorten up our proof though and use the following. So let's say that this is a transversal. Wouldn't you agree that on this transversal with these parallel lines that this angle right here and this angle right here are congruent? Why? What kind of angles are they? Alternate interior angles. Couldn't I say the same thing on this one here? Couldn't I say that these right here are congruent and these are congruent? Because they're also alternate interior angles. And that will give me my AA. The only reason why I'm going to choose to go that way rather than the vertical angles is because I can do that in one step rather than two different steps. It shortens my proof. So let's start off with our given. Segment LP is parallel to segment MN. Why? Given. From this given, I conclude that I have alternate interior angles that are congruent, so I have to tell exactly which ones they are. So I'm going to start with that one. So angle LP, I'm going to go all the way to M, is congruent to angle, I'm going to do this one, PMN, and angle PLN is congruent, I'm going to do this one, to angle LNM. So those are the two pairs of corresponding angles that we just arc marked up there. Why are we concluding that they're congruent? Corresponding angles are congruent on what? On parallel lines, right? Because this is A and then A, can't we immediately jump to our triangle congruent statement? So let's see if we can do it right this time. Triangle LJP is similar to triangle, what corresponds to L on this triangle? With arc marks, what corresponds to L? N. What corresponds to J? J. And so that leaves us with M as in Mary, right? Why? What theorem did we use to prove the triangle is congruent? AA similarity. The minute we do AA similarity, we've proven the triangles are similar, then aren't any of their corresponding parts also proportional? So I can go immediately to that proof statement of LJ is to JN as PJ is to JM. And the reason is that corresponding parts of similar triangles are proportional. Done.